Jetzt, mir werden hier die Überleitungen einfach zugespielt. Ne? Also wir hatten jetzt vorhin Bundesliga, jetzt kommen wir schon in die Champions League der Messgeräte. Rohde und Schwarz ist, glaube ich, die Marke, die wir so, wenn man bei uns im Verlag reinläuft und dann links abbiegt ins Testlabor, die am häufigsten vertretene. Also noch mehr als da Marken von Smartphone-Herstellern auftauchen, Rohde und Schwarz vorhanden.
Was auch, wenn ich unterbrechen darf, daran liegt, dass die Geräte einfach unverwüstlich sind. Wir haben noch Geräte, die aus der 2-3G Mobilfunkgeneration stammen und immer weiterlaufen.
Aber jetzt ist der Christian Müller, steht ja hier, Senior Sales Manager. Das heißt, Sie müssten eigentlich an der Haltbarkeit arbeiten. Also offensichtlich scheinen die Produkte zu haltbar zu sein. Aber wir freuen uns, dass es so ist und auch auf Ihren Vortrag, den eigentlich auch nur ein Mann aus dieser Branche formuliert haben kann. Weil wenn ich jetzt zu meiner Frau sagen würde, heute erlebst du the beauty of 5G Network, nee, erleb du das mal allein. Ich erlebe da was anderes. Aber wir freuen uns sehr, sehr auf Ihren Vortrag. Und herzlich willkommen.
Herzlichen Dank und erst einmal zum Auditorium. Ich habe nichts bekommen für die Werbung, für den Einstieg mit unserer Messtechnik.
Ja, wir auch nicht.
Wir sind froh, dass es so ist. Yeah, I would like to change to English. I think there are some international colleagues listening and so on. Yeah, beauty of 5G network performance. We've heard a lot today about all this industry, all these new use cases and so on. And for us as Rohde and Schwarz, we have, is okay?
Everything.
I need to check here. For us as Rohde and Schwarz, we have all the challenges to define, to develop test methods for these mobile networks, for user equipment stuff, where as well Connect is doing quite a lot in this area. Security comes along. So these are all different areas where we need to define test methods. And this is our beauty in this area. I would like to strive here. Where I'm coming from, so I'm proud that I work already for a few decades for this privately owned global company with more than or close to 90 years of success. A lot of employees worldwide. So it's nice to be in such a company with such a long history in this area. And I think we have a lot of expertise which we can bring to these topics I would like to address today. So we talk about infrastructure, we talk a little bit about operations, we talk about devices, and as well we are striving some areas around test labs. If I go for 5G, the testing landscape has been completely changed. So we have new players. We have non-human use cases. We have 5G use cases with a lot of requirements in terms of interactivity and real time. Services become more and more critical as well. And one point which I would like to strive here, it's a kind of helicopter ride of a 5G enterprise network or as well normal network, is security and asset protection. This does have implications for the testing. So the quality requirements are different between the different use cases. Interactivity, we call it, is the key for these 5G services. We have additional quality of service evaluations on IP layer and as well quality of experience on application layer. And the protection and security for as well the mission critical use cases. One of these new players in this market is as well Rohde and Schwarz. So we decided 2 years ago that we want to create our own 5G campus network. We decided to deploy it in our factory in Teisnach. And what else could be better for such a company? We have our own company, our own factory with our own network, and it helps us to innovate mobile network testing product and service for our portfolio. Currently, it's an experimental network. We try to play, and a lot of these enterprise networks are today in a kind of experimental use case. We see how difficult or how easy in some areas it is to deploy such a network. The deploying or the installation is pretty okay, but then to get the performance, what you want to achieve, this is a real challenge. And I've heard always already 20 years ago, you don't need any test and measurement equipment in future. The networks are pretty easy. You just install it and everything is working. Luckily, I'm still not unemployed, and we can provide some of this equipment for as well bringing such networks into service. So today, after some fine-tuning and performance tuning circles, we are reaching around 700 megabit, but I'm a single user in this network at this time. And we have latencies where we talk about in a range of 15 milliseconds what we can achieve. So for us, it's a good playground where we can go in and where we can get some experience. And one of the very important starting areas is some network testing solutions where you can do a kind of site acceptance and where you can do a performance tuning. And we, as a provider for drive test equipment, for optimization equipment and so on, we decided to use as well for this site acceptance and for this field service part the experience and the performance of our scanners. And we are using here an instrument. It's a site test solution, which is pretty easy to operate. And it's a scanner just with an easy Android user interface to operate. This is a passive test where I just check the downlink signals of the sites, the installed sites, and this mainly focusing on the signals which are important for a device to synchronize or to connect to. For this performance tuning, I have to go and I have to use in addition a user equipment. And for 5G, since we are mainly talking about machine communication, not human communication in this area, we are using industry modules. So all kind of industry modules which we are combining with such a passive tester. Why it is so important in such a factory, I just would like to give some indications here is, we have partly very harsh radio environment. We have typical industry-grade housing, which is not always very nice to RF performance which is needed. We have multipass environment. You can imagine you have all these metallic machines in such an environment. And when some of the factory owners are saying, oh, everything is radio, I don't need any cabling anymore, I can say every time you change your production environment, you get different radio conditions. So we learned here, it's important to do this kind of performance tuning on a regular basis. And interferences. So all kind of interferences, what we measured already. I can talk there about hours, about some really partly funny stories, what kind of interferences we could get here. But anyhow, so if I select this solution, or if I go in after a deployment, the first thing I have to do is a passive network testing. So I need a receiver which can see all the downlink signals which are important for a device to get connected. And the first thing what we are doing is we are running an automatic channel detection. So I just tell my receiver what kind of technologies what kind of bands I want to measure. And if I'm in an industrial environment, I'm partly as well interested what kind of networks I have maybe around this environment. So this is just putting an antenna on air, and you get a complete overview. And even here on the screen, it's a little bit too small, but what's interesting here, for instance, in band 1 was a measurement. I saw LTE in band 1, and I even measured 5G in band 1. And this was a dynamic spectrum sharing situation, which we've been able to find out. Most of the measurements in industry areas we do today on band 78 in Germany, where these private campus networks are got their license. Another interesting situation, what we've learned so far, we are working today in a TDD network. And synchronization, we've learned, is one of the key elements. You can imagine you have on the same frequency downlink and uplink. And there is a very strict time allocated for the uplink when the device is allowed to transmit a signal up to the base station. And if you have now several base stations and they are not time synchronized, it can happen that in this time window, where normally the device has to transmit, you have a strong downlink signal. This you will see in a not so good signal to noise ratio. And in worst case, it can happen that your device is trying to send data up to the site, but the site is completely blind. It doesn't hear nothing because there is a strong interference. So we spent quite a lot of time here, and we worked very close together with the German operators, and I was traveling globally, so I've been in Japan, in China, in Korea, and so on, and this synchronization was always an issue which we have to find in a very easy way. I've heard from a situation for an indoor deployment, and there was a GPS offset programmed in the basement hotel, managing 8 sites. And the maximum throughput they could achieve was in a range of 10 megabit. So by far not what they wanted to have. And they were wondering why the devices are not getting a higher modulation coding scheme. So these are some examples which can happen, and why such a network testing is crucial. Now I want to just show an example here where we can combine such a passive tester together with an active tester. And the active part will be played by a user equipment, by an industry module. So I combine this industry module together with such a scanner. The scanner is measuring with 20 hertz sampling speed. A device is testing or measuring with about less than a second, less than hertz. And devices are allowed, according to 3GPP, to have, when you measure or when you want to read out the levels, the RSRP, the power level, or the signal to noise ratio, which are elements for the scheduling. According to 3GPP, such devices have a tolerance of about plus minus 60 dB. Plus minus 60 dB for technical guys is quite a lot. Yeah. So what we are doing here is we are combining the information of a very fast measurement receiver in combination with the device. And you can see here on the screen for the RSRP, which is the power level, the blue line is coming from the device, and the red line is coming from the receiver with a dedicated antenna, much faster. This is, for instance, a setup which is used for the development of industry results, where you can even try to find out where is the best place to put an antenna on a robot or on an HEV. Not to forget the spectrum view with statistical measurements, so you can see the uplink and downlink parts and so on. That's all more or less for troubleshooting. So if you don't get the result as you are expecting, this is the way how we are moving forward. We talked about the network. Let's talk about the devices. It's important to have different test and measurement equipment for the different stages, from RF design, development, up to production, and RF and application performance. And I think Connect can show some experience here, because that was mentioned before, where some of our equipment is placed there. Why is it important? Normally you can say a device is certified and everything should be okay. But if you look on such a device, you see here it's not only 5G in. You have a lot of implications. There is the antenna, there is the near field communications, there is the Bluetooth, there is Wi-Fi, there is GPS. So there are a lot of different signals back and forward. So it's important to do measurements for the different use cases of such devices. When we are talking about this kind of use cases, I'm in contact with manufacturing, with warehouses, with mining, ports, critical infrastructure, energy industry, and so on, where 5G network solutions are tested. So on the mining side, for instance, we saw here a big project, or we are working together for a big project, where even with artificial intelligence, the control of the autonomous driving trucks will be managed, and you need coverage, and you need interactivity with very low latencies and a certain throughput. So it's a very interesting field as well for me. I enjoy very much, where I talk mainly to operators and infrastructure suppliers in the past. Now you talk to users and to design engineers and so on for this kind of new use cases. It's a completely new game. Which brings us to the next part, where we need to find a way how we can measure this higher level of quality. So what we are doing here is, legacy technologies mainly was focusing on human users, voice, video, data, and so on. This has been the optimization criteria. Today, we have to know more about this interactivity. We have virtual reality, we have augmented reality, we have V2X, as we saw just before in the automotive area. So we have a lot of new areas where we just need, beside data rate, as well as the reliability and the extreme short transport latencies. So what to do is, in a way, that we have to find an interactivity test which combines bitrate, latency, continuity, and availability. And in past, you just send a ping for doing some latency tests. But since most of the applications are done on UDP, you have to find a way to do these latency tests on a UDP stream. And our answer is here that we are using this TWAMP protocol. This is specified. And you put on your server in your campus network, or which you want to approach with your industry device, you put a console, and this is just like a mirror to the protocols what you are sending on UDP. So you can define the throughput, you can define the bit rate, you can define the size of the packages, and then you get a certain latency information really in your campus or in your environment. So this is something we are working very close together as well on the ETSI, we made some proposals, and the interesting part here is that I can define certain profiles, and I can generate certain scores for different kind of applications. And there is one score, for instance, for e-gaming, where you can say, okay, you need about 20 milliseconds round trip time, then it's a perfect situation. Or you can go for scalable tablet connectivity, where a delay of around 60 milliseconds is even okay. Or you go for a robot control, where you need about 10 milliseconds. And the beauty here is that it is a scalable way of measurements and scoring related to certain use case scenarios. So we talked about network, we talked about devices, we talked about quality of service, quality of experience, and I would like to make a short flight over to some security parts. So security, we consider cyber attacks. Asset protection is something which we are more and more confronted in. And let's make us right through this section here. Main three pillars for trust in IoT. We have device security, which is to verify the certification and to see the whole life cycle, endpoint security. Network security, we need set of technologies, we need probes to find certain threats, certain attacks, and so on. And finally, a kind of monitoring to make it visible with the vulnerabilities what we have in such kind of networks. For the device security, the endpoint communication security is one of the bigger threats in this IoT environment. So you need to know the application, the protocol detection. You need to see more about this cryptography algorithms and as well geolocation. This is something where we have solution by using a deep packet inspection, which is developed by ourselves in our lab in Leipzig by IPOC, where we combine this way of evaluating what kind of protocols are running or are enabled from such a device. If I go to the network part, the network security, the traditional networks security is working pretty well against defense cyber threats, but we've heard about more than 90% of attacks did not generate an alert. We have a lot of attacks which allowed unnoticed access, and this is something where we need to look on. We need a certain detection probing, and DPI or IP, deep packet inspection part. We need to analyze and correlate this kind of protocols by AI and artificial intelligence and machine learning. And then at the end, we need as well to have a certain reporting and alerting. This is the combination here of this detection and analysis. Yeah, the next part, which I just wanted to show you, jamming. You need to protect your industry environment by intentional jamming or unintended interferences. You need to do a kind of monitoring on layer 1 to find this kind of interferences as well. These are solutions we are working on, where we have an artificial intelligence-based spectrum monitoring, where we have certain probes distributed in the environment. Drone protection is something which is more and more important, that you can allocate, detect, classify, and locate such drones. So it's as well a kind of warning systems. And for the asset protection, body scanners. This is by microwave imaging technologies. And just to give you a little bit an impression what's going on there, per scan, we are reading about more than 2 billion readings. And just by artificial intelligence and so on, we can detect things which shouldn't be put into in a factory. So on airports, it's a security check-in. In warehouses, it's loss prevention. Yeah. And as well in productions, or where you have certain research or wherever in the industry, where you have to make sure that not things are leaving your entity which shouldn't. This kind of body scanners are part as well for this kind of asset protection. So it's just here on the airport, when you see it, some of the scanners, we're working on a new solution where you can just walk through, so where you can test around 700 people an hour. Just here on the airport, you have to imagine there is, in each panel, there are around 3,000 transmitters and receivers. And the beauty here is that such an instrument can be installed within a day and calibrated in a day. And there we have quite a lot of intelligence in for a proper and reliable scanning. So that was a race, a helicopter flight for some measurement methods which play a part in this 5G world. Yeah, I'm proud to be in such a company with a lot of experts, with a lot of experience and leading edge solutions. And we are working in a lot of this the 3GPP standardizations and 5G ACAI. So we learn a lot about use cases and so on, what's coming up. So thanks for this helicopter flight. And if there are some questions, I'm happy to hear, and I hope I can answer.
Ja, ich bin im Kern ja beeindruckt, wie wir den ganzen Tag über in diesen 30-Minuten-Slots geblieben sind. Jetzt sind wir eine Minute 30 drüber, aber gleiches Recht für alle. Also eine Frage würden wir dann doch noch stellen. Ich vermute mal, der Bernd möchte
Hätte eine.
Jetzt
denke ich fast auch. Ja. Ich hätte zwar auch eine, aber Bernd soll bitte.
Also da gäbe es sicherlich viele Diskussionspunkte. Was mich interessieren würde, ist, wenn ich gucke, was da jetzt alles an Messtechnik auf uns zukommt, ist, ob Rohde und Schwarz auch ein exponentielles Wachstum gerade erlebt durch 5G. Also kommt einem das nur so vor oder sind das deutlich mehr Äste, die Sie mittlerweile ja verfolgen müssen?
Also was uns hilft, sind die mehreren Äste. Ich kann sagen, exponentiell ist es nicht. Aber also wir werden in vielen Themen inzwischen gefragt, wo wir dort Lösungen bieten können. Ja. Und inzwischen merken wir auch, dass schon 6G kommt.
Komm, Hannes, jetzt interessiert mich deine Frage.
Ganz schnell wollte ich nur die Anekdote noch aufgelöst bekommen, irgendwie das Hotel, wo im Basement die Datenraten eingebrochen sind. Woran lag es denn dann?
Ich hätte eine Lösung, die könnte man mal implementieren und mal anschauen.
Also was hat da gestört? Was war da?
In welchen?
Sie hatten ja gesagt, Sie haben mit dem mobilen Scanner in einem Hotel mal geschaut, irgendwie, weil die gesagt haben, wir erwarten viel mehr Datenrate als das, was wir rauskriegen.
Also dort hat man ein Problem mit Synchronisation, dass da zufällig eine zweite Station hochgefahren wurde, die war nicht synchronisiert. Und dann war da ein ziemlich hoher Signal-zu-Rausabstand und die Station wurde abgeschaltet und dann ging es wieder.
Sorry für den Ingenieursporn, aber das hat mich jetzt doch interessiert.
Ja, das macht nichts. Ich habe den Teil nicht verstanden, aber das ist auch nicht schlimm. Herr Müller, vielen, vielen Dank, dass Sie da waren.
Danke.
Also Helikopterflug ist auch immer gut. Ja. Viele Impressionen zu, ich glaube, 4 wichtigen Themen. Freut mich sehr, dass Sie da waren.
Dankeschön.
Dankeschön.
Danke.